Let's begin. Oh, now you actually need to. So, shift your brain into physics mode, and let's begin. So, looking at velocity time graph, average acceleration. Now, I think I've already told you that the slope of a VT graph is the slope of the VT graph is what quantity? Go ahead and say it. You're right. Acceleration, right? The slope of the VT graph, and there, have you got space right there? Slope of the VT graph
Right there.
is equal to the acceleration. Do I have it somewhere right there? There it is. A is equal to the slope of the VT graph. Okay, so because it's slope, all of those rules that applied to velocity for DT graphs apply here. At the end of all this, I'm going to give you a chart that explains everything all on one neat page, sort of a how-to list. Okay, so average acceleration is calculated the same way that average velocity is calculated on a position time graph. That is by using the slope formula. So if you haven't learned the slope formula yet, it's time. You've done it in math, you've done it here lots. You need to know the slope formula. Okay, acceleration for interval A. So I'm going to give you an example, and then guess what I'm going to do? You're going to do it. So here's the part where you listen so you know how to do it. So acceleration for the interval A. A is the first one. This is going to be A from 0 to 2, B, C, I think D is down there, E and F. I think I've got them listed. Okay, so the slope of this highlighted area right here. How do we find slope? Rise over run, Y2, right? The Y's on top. So what's Y2? 4. Y1 is 0. So I went up 4. 4 minus 0. It's not listed here. If you want to write it, you can write 4 minus 0. What's the run? It goes from 0 to 2, or 2 minus 0. Right? So it's rise over run, 4 minus 0 all over 2 minus 0, 4 over 2, or 2 meters per second squared. Now we had a little issue with some of the handouts there, some of the hand-ins, the units. You got to get this straight. Acceleration is meters per second squared, velocity is meters per second, and displacement is obviously meters for now.
I'm going to send you an email a little bit more tonight.
So I want you to find a bar for each interval. I'm giving you the answer to the first one. Boosting your clicker mark. So what is the slope? 2 meters per second squared. So if I start this, I'm just starting it now, yeah. You should be able to answer number 1. What is the answer? 2. The clickers obviously don't allow you to put in units. So enter 2, and then I want you to find the slope for B, highlighted, C, highlighted, notice that it only goes down to there, D, E, and F. And then there's another answer to number 7, another question, number 7 there. Oh, then there's 8, and 9, and 10, and 11. So there's 11 questions for you to try. Oh. The Y value here is 0. The Y value here is minus 3. You have to be careful with subtract minus 3, don't you? All over, 14 is the X, 11 is the X. 3 over 3 or plus 1. Remember, negative slope means Lance, which way? Negative slope means down, positive slope means up. Okay, here's the brain tickler ones. When is this object stopped? Correct answer, drum roll please. G, never. Why is it G for never? Exact. How many people put these ones as stopped? That is true when the graph is displacement, but this is a graph of the velocity, is it not? So for the to be stopped, that means that the velocity must be 0. Are there any intervals intervals when the velocity remains 0?
No.
There is an instant when it is 0, right there and right there and right there, but those are not intervals. Those are instances. So it's momentarily stopped. That is a tough question. That is something I expect you to know. Wink, wink, nudge, nudge. You know, maybe in the future. When is this object moving backwards? It's a velocity time graph. So when it is moving backwards, when the velocity is negative. Anyone think that might be something you might want to write down? The velocity is negative. When is the velocity negative? D, E, and F. There and there and there. The velocity is negative, meaning that it is moving backwards. Nod if you get that. F is going up. Good point. F is going up. But again, remember, this is a graph of velocity. We're not thinking about the slope anymore. If we're talking about speed, we're talking about the value. So the value here is negative, the value here is negative, the value here is negative. What does it mean that it's going up towards 0? It means it's going negative, but it's
Moving.
no, slowing down. Why slowing down? Because it's going to 0. I'm in agreement. It's not easy stuff. I'm going to have to go over it over and over. When is this object slowing down? It is slowing down for C and F. A lot of people picked that. That's good. A, B, C, and F. Why? Because the graph is approaching 0. The graph is moving towards 0. Who thinks that might be something important to write down? Oh, you can't put your hand up because you're too busy writing it down. That's a hint. That's important. Don't be lazy. The object slows down when the VT graph approaches 0. The velocity is getting closer and closer to 0. 0 is stopped. Slowing down. Am I making sense? When is it speeding up? The opposite of slowing down is speeding up. If slowing down is approaching 0, then speeding up is moving away from 0. And so the correct answer is A and D. Very good. A and A, B, C, D here. It's a little bit counterintuitive. Remember, we're not talking about DT graphs anymore. We're talking about velocity time graphs. So it is A and D. When is the object moving at a constant speed? Constant speed means that the velocity stays the same. Velocity stays the same. So when is the velocity remaining the same? B and E. There and there. How can you tell that the velocity is staying the same?
Straight line.
Flat.
Flat line. Flat line. Is that making sense to you?
Yeah.
Is there any more? Oh no, now we're done. Okay. Okay. Displacement. Displacement from the VT graph. How many people know what area is? Probably about grade 4 or 5, maybe, right? Area of a rectangle, length times width. Everyone knows that. Area of a triangle, base times height,
Divided by 2.
divided by 2, or if you prefer, times by a half. If you can do that, you can do this.
Yeah.
And I know you can do that because you're sitting here in grade 11 physics and you must have been able to do that back in grade 5 or 6. So, displacement on a VT graph is determined by calculating the area between the graph and the time coordinate over the time interval in question. I'm going to highlight that. Displacement on a VT graph is determined by calculating the area between the graph and the time coordinate over the time interval in question. Calculus professors like to say, finding the area under the curve. Calculus professors also don't like it when the curve is down below, so I hesitate to use the word below the curve. It's the area between the graph and the time coordinate. When I say the time coordinate, I mean the time axis. That blue line right there. The area between the graph and the time coordinate for that interval in question. That shaded in rectangle, you guys have it shaded in, don't you?
Yeah.
Excellent. Area. What shape is that, Lance? Triangle. Formula for area of a triangle? Base times height divided by 2. I've got 1/2 the base times the height. So in the example, we're going to do this the same way. I'm going to give you an example, and then you're going to do, in the example, the displacement for the time interval, 0 to 2 seconds, would be equal to the area of the triangle formed by the graph and the time coordinate. That blue one that I just shaded in. Because it's the area between the graph. Here's the graph. Here's the x-axis, and it's for the interval 0 to 2. So I stop it there, and then I shade. If you want to shade, you can. So it's 1/2 the triangle, 1/2 the base. What's the base of this triangle? From 0 to 2. There's my base, 2. What's the height of my triangle?
4.
4. 1/2 times 2 is 1, times 4 is 4 meters. The area here is 4 meters. This object moved 4 meters, and it took how long? 2 seconds. Nod. I can do that, Mr. Matt.
I can just do 8 or 8 times.
Yeah, 4 times 2, 2 times 4 is 8 divided by 2, sure. Okay, now, what if I want to know more than one time interval? If more than one time interval is to be used in the calculation of displacement, then the total displacement is the sum of the displacements of each time interval. That's complicated talk for add them up. If the displacement for the intervals A and B were to be calculated, the following technique would be used. So if I want A and B, B goes to here, 5 seconds. There is the graph. There is the time coordinate. I'm going up to 5 seconds, so I shade it in. What shape is it, Lance? This one right here. Rectangle. Area for a rectangle, Lance? Length times width. So here's area A, 1/2 times 2 times 4. We already did that. What's the length here? From 2 to 5 is a length of 3. What's the height?
4.
4.
Oh,
Yeah. Be careful. 3 times 4 is 12. Add them together. The total displacement for those two intervals is 16. If the graph is below the time coordinate, what do we do? If the graph is below the time coordinate, then the displacement is negative. Why is it negative? Velocity is below 0. The velocity is negative, which means it's moving backwards. Now, be very careful. Interval D. This is A, this is B. This one here is C. I haven't done it. This is D. Now, here's where the classic mistake is made. It's the area between the graph and the axis, right? There's the axis. There's the graph. It's the area in between. It's that triangle. It's the area above the line. Okay? I get this all the time. I get this guy down here. What's wrong with that? It's not between the graph and the time coordinate. It's just below. People get in the habit of going below. Bad habit. It's the area between the graph and the time coordinate. Okay? So for here, it's a triangle. The base is from 7 to 8.5. That's a distance of 1.5. The height is from 0 to -3. So I've got 1/2 of 1.5 times minus 3 minus 2.25. That's the interval D. Can you do these now?
So you're always timesing it by 0.5.
Well, if it's a triangle.
Yeah.
Okay, I want you to find interval C, interval E, and interval F.
Triangle there?
The first one's a triangle. Yep, you're on the right page here. Are you finding slope this time? No, you're finding area.
So would interval E start right here?
C is this one. E is the same as before. There's E. E is the flat one. It'll be a rectangle. Good. E is from 8.5 to 11.
You just use the formula you would length times width.
Length times width. Area of a rectangle.
Since this below line would be a negative.
F is the next one here, yeah? Is there more than 3 questions? Just 3, good. Okay. In all cases, you are finding the area. Why the area? Because you're looking for displacement on a VT graph. That's the rule. Again, I'm going to give you a big list of rules here right away. So, this displacement here, we're talking about this triangle right here. Right? The base is from 5 to 7, so it's 1/2. From 5 to 7, Lance, is how far? 5 to 7. 2. 1/2 times 2. What's the height? 0 to 4. 2 times 4 is 8. Times 1/2 is 4. 4 what, by the way? Meters. It's displacement. 4 meters. Interval E. It's a rectangle. It goes from 8.5 to 11. That's a distance of 2.5, isn't it? Do I have to go 1/2 times? It's not a triangle. 0 down to -3. 2.5 times -3. 6 minus 7.5, right? Minus 7.5. How'd we do?
Forgot.
Not bad.
I forgot to put a minus.
Oh, we had lots of different answers, it looks like. This one here, interval F. It's a triangle. 1/2 the base times the height. The base is from 11 to 14. That's how far? 3. The height is from 0 to -3. 3 times -3 is -9, and half of that is -4.5 meters. Listen up, you guys. -4.5. It's below. Okay, now, last little bit here. I know I've thrown a lot of stuff at you. I intend in the future to split it into pieces, but unfortunately we're going to have to deal with it this way today. The last one. I know it's been a long class. You'll get time to work tomorrow, promise. Average velocity. Guys, refocus one last time. Whenever the average velocity is to be calculated under any circumstance, it must be done using the formula V equals d over t, where the displacement is calculated from the VT graph using the area under the curve technique. That whole thing should be highlighted.
We don't have a graph.
To find average velocity, you got to find the displacement first, and then divide by the time. Is it not there, Cole?
They're just split up.
Well, and then we don't have the.
So it's on the next page, isn't it?
No.
It just doesn't have that graph there, you're right. Same graph. Average velocity. It's on the very next page. Average velocity, how do you do it, Lance? You take the displacement that you just figured out using the area technique, and then divide by the time. Let me give you an example. That's the average velocity, because we just did displacement, right? V equals d over t, right? The average velocity for the time interval A and B. A and B. Here's A. Here's B. So we're going to find the displacement.
But the displacement for B is 12.
Yeah, it is. For B, it goes from 2 to 5. That's 3. Up to 4. 3 times 4 is 12, right? This is 12. Right? That's 12, and this one is 4. Now, some people might say, can't I just go like 0 and 4 and find the average? 0 plus 4 is 4 divided by 2. The average is 2.
No.
No, because it's clearly at 4 for a whole lot longer than it was at 0, isn't it?
Yes.
You have to wait more on the 4. It'd be like me giving you an exam worth 90% and you getting 3% on it, and you got a quiz worth 10% and you got 100. You can't just add them together. Right? You got to weigh them. Same idea. Oh, hello. That's me, I think. No, I'll just ignore it. It's no unimportant. So, D equals area of A plus area of B. So the area of A is 4. We did that before, lads. We did that before. The area of B is 12. We add them together, we got 16. How do I find the average velocity? Take that 16. Where did I get 5 from? 5 seconds. 0 to 5 seconds. 16 divided by 5 is 3.2. I want you to determine the average velocity for the entire trip from 0 all the way to 14. Do you have the displacements, all of them? You should. I hope you wrote down the correct answers. If you haven't, let's do it right now. What's A?
A equals 4.
4. What's B?
Negative 7.5.
No, B. 12. What was C?
4.
4. What's, oh, I didn't do D. What was D?
4.
D is down here, minus 2.25, right? D was minus 2.25. What's E? Negative 7.5. And the final one, F, minus 4.5. How do we find the total displacement?
Can you do the 2?
Add up all those individual displacements and divide by the total time. Add up all the displacements and divide by the total time.
Just went to 1 decimal point.
1 decimal point. Instantaneous velocity. Now, stop, change gears, think a bit here. I know I've thrown a lot at you. It's a velocity time graph. Instantaneous velocity means what? Speed at a particular instant. How do we do it on a VT graph? It's easy. Just read it off the graph. That's all you got to do. Instantaneous velocity is read directly off the VT graph. It's a graph of velocity. So V inst at t is equal to 6 seconds is? At 6 seconds, what's the V inst? 2. You read it off the graph. Read it off the graph. Why am I repeating myself? You read it off the graph. Quick check. What is V inst at 13 seconds? What do you do? Read it off the graph. Go ahead and answer it for number 2.
It won't let me go to. It says
You know what? I haven't started yet.
Let's review.
Okay, so let's go back and do this one here. Let's finish this one. 0.4 was your answer for the last one? Awesome. Let me start this one. We're reading it off the graph. What's the velocity at 13 seconds? Minus 1. You read it off the graph. If you're sitting, if your name is up here, you should be entering it.
William.
You read it off the graph.
Billy, you're gonna wreck your average now.
You read it off the graph.
Come on, Bill.
What if it's not negative 1?
Billy, it's negative 1.
Negative 6. Right, I'm gonna put negative 2.
Oh, too bad I stopped it.
Wait, Kate.
It's minus 1.
I was entering it. It wouldn't let me enter it.
Okay. Last one.
Now I got 0.
Instantaneous acceleration. Refocus. I know it's very close to 10 o'clock. Only the leaf shut down when there's not much time left. The instantaneous acceleration is determined the same way off a VT graph that V inst was. Acceleration is determined the same way off VT graphs that V inst was determined off PT graphs. That is, find the slope. Find the slope. You may need to draw a tangent line. When do we draw tangent lines, Lance? Listen. Don't talk. I'm talking. When it's a curve. Very good. You draw tangent lines when it's a curve. If it's a straight line, you just
Read it off.
find the slope. Find the slope. So A inst at t is equal to 12 seconds. I want to know the acceleration here at 12 seconds. How do you do it? Find the slope. Find the slope. Go. You do know how to find the slope. Really, man? Rise over run. Find the slope. Find the slope at 12 seconds.
Multiplied by negative
Find the slope.
2.
All right. Okay.
Find the slope. Find the slope. Who is making that noise? Stop it, Graham.
It's just one.
No, it's not.
Find the slope. 0 minus minus 3 is? 14 minus 11 is?
1.
Find the slope. Okay. I will start tomorrow. This next page is everything you need to know, all on 2 pages. I will start there tomorrow.
Listen to you.
Okay? Make sure you're on time to hear that part.